So good afternoon to one and all. The previous class we had discussed about location of the harmonic sources. That locating the harmonic sources we have discussed. And the introduction part we have already discussed about what are the harmonics, how the numbers, the multiple integer number it is going to increase, and distortion and all the things. Okay. So the today class we are going to discuss about how the power system is going to respond, what its character of the power system for the harmonics. That one we are going to discuss in the today class here. Okay. So is it audible? Anyone can tell me?
Yes, sir.
Okay. Is there in the computer lab? Please sit silently. Don't make a noise. So the power system, it is going to hear the harmonics will produce us, but how the system, the actual power system, it is going to response that one, and what are its characteristics, that one we are going to discuss. Actually mainly the primary variables for the affecting the harmonics or whatever the power system response is nothing but depends on, that is the characteristics is depends on the system impedance and presence of capacitor bank, it is present or not. If present, what will happen, then amount of resistive load during the resonance or resonant, and that condition what is the amount of resistive load will be there in that. So these three are the major characteristics, that is variables we are going to call that one, primary variables which are affecting the system response characteristics. So in this system the response of the system is equally as important as sources of harmonics here. For the sources, the system response is very important here. We are going to tell that. It is quite tolerant of the currents injected. Harmonics, what they are going to do, they are going to inject the current, which is nothing but they are going to produce the load over there. Harmonics production, they are producing the loads. That is called increasing the current or injecting the current. That unless there is no some adverse interaction with the impedance of the system. So without interaction with the impedance over there, if we are injecting a current, we already know that one, the impedance and currents both are inversely proportional. Yes, so that will affect the impedance of the system. That is the primary variable affecting is, that is called system impedance we are going to consider. we are going to consider, that is the primary variable, that is system impedance. So identifying the sources, what are the harmonic sources are there, those to identify. Once we identify this, means that is half of our work is completed. Harmonic analysis, half of work is completed. So the 50% of the work is related, that is called the time consumption. The analysis, it will go for the harmonic source identification. What are the harmonic sources? How to identify? So that is, identifying the sources is only half the job of harmonic analysis. Then the response of the power system at each harmonic frequency determines the true impact of nonlinear load on harmonic voltage distortion. Next, how the power system is going to respond for each harmonic frequency variations, that is determines, that is called true impact of nonlinear load. The harmonics are produced by the nonlinear load. So how it is going to impact, true impact of nonlinear load on harmonic voltage distortion. Already in the starting only we have considered that one, how the harmonics are there, what is the fundamental waveforms, then the harmonics and the fundamental waveforms, combining those two, we are going to get, that is distortion waveforms we are going to get. So that one we are already discussed. So there are three primary variables affecting the system. Those are the system impedance. Just a minute. So the system impedance, presence of a capacitor bank, and amount of resistive load in the system. These three are the primary variables affecting the system characteristics here. Now response characteristics, it is going to affect here. Now one by one we'll discuss that one here. That is, first one we are going to consider, that is the system impedance, that is called Z. We are going to call that one here. So at the fundamental frequency, power systems are primarily inductive. So whatever the Z we are going to consider, that is inductive and capacitive, we are going to consider Z equal to R plus JX. The X is nothing but net reactance. That net reactance we are going to consider as primarily it is inductive only. Okay. And the equivalent impedance is sometimes called simply short circuit reactance. So whenever the harmonics will inject the currents, the current injection is nothing but the impedance will be reduces over there. So if there is no opposition at all to the current, that is nothing but it acts as a short circuit only. It acts as a short circuit. In the short circuit only the current will be more. There is no opposition, is nothing but there is no resistance or impedance at all. So on that condition, what we are telling here now, the equivalent impedance is sometimes called, whatever the equivalent impedance is there, sometimes called simply the short circuit reactance. We are going to call that one here. That is called short circuit reactance here. So that is primarily we are considering as inductive only, but the capacitive load is also there, that one. So Z equal to R plus JX, we are writing the X is nothing but that is net reactance. By cancelling the impedance, capacitive and inductive reactances, whatever the excess is there, that one primarily we are considering as inductive over only. But capacitive effects are frequently neglected. Whatever the capacitive effects are there, that is neglected on the utility distribution system and industrial power system. In the utility distribution system and the power systems, we have neglected the capacitive effects. But on the other places we are going to consider. So one of the most frequently used quantity in the analysis of harmonics on power system is that is nothing but this one, short circuit reactance. That is, reactance is nothing but impedance, we are going to call that. Short circuit impedance method. Short circuit impedance to the point on the network at which capacitor is located. At which point the capacitor is located, on that point we are going to consider here. So to measure this one, there are so many methods are available. if not directly available, so it can be computed or indirectly we can measure that one. Short circuit steady results that gives either the short circuit mega volt ampere, that is called MVA. Volt ampere is nothing but apparent power output here, no, or the short circuit current it is going to give that one here. So here you have to understand that initially that is primary inductive. So capacitive effects are neglected for the utility side and industrial power side here now. Okay, and frequently used quantities, that is nothing but harmonics we are going to consider, that is called short circuit impedance method we are considering here now. So we can use either the short circuit MVA, that is called mega volt ampere, or short circuit current we can use for the characteristics of this system impedance here now. So the second point, that is called presence of a capacitor bank. Normally, why we are going to use the capacitor bank? The capacitor banks are used for the power factor corrections only. Okay, we are going to use the capacitors in the power factor corrections only. But if the inductive load increases, on that one, whatever the inductive reactance is there in the circuit, it is going to increase, means the capacitive reactance will start to decrease over there. Normally, what is that? The capacitor will not affect anything, but during the distortion time, whatever the harmonic distortion time, if we have installed the capacitor bank, it is going to give very high effect it is there. For that reason, so we have to consider capacitor bank also that characterize the power system we are considering that one. Okay, just a minute. 1657. Okay, so I'll start reading. I already explained generally. Send capacitors either at the customer location for the power factor correction. So capacitor banks we are going to use for the power factor correction. Also we can use for the voltage control also. Some places that is called distribution system we are going to call. So on the distribution system for voltage control, see either the customer location for power factor corrections, distribution system for voltage control. So for the two purposes, we are going to use the capacitor banks. Okay, one for power factor correction, another one is voltage control here now. Dramatically alter the system impedance variation with frequency. If the harmonics will vary with frequency, that is, we are going to the domain, frequency domain we are going to use for the harmonics. So if the system impedance vary with frequency, then it is going to alter that one. The capacitor will alter that over there. So it will produce the problem. But generally what we are going to consider, the capacitors do not create any harmonics. Capacitor will not create any harmonics, but already due to some other harmonic condition that will, if we have connected a capacitor, but that will, if the harmonics are present, that will create a very severe problem it is going to create. That is, whatever the distortion output is there, that will very high value like this, it is going to consider like this here. Here, capacitors do not create any harmonics, but severe harmonic distortion can sometimes be attributed to their presence here now. They are going to, their presence, whatever the capacitor presence are there, be attributed their presence, that is going to cause that very severe issue or distortion, it is going to cause that one, we are going to call that. So their presence here. While suppose we are using a capacitor bank, but the inductive component is increases proportionality to the frequency, then what will happen? If XL is increasing, then XC will start to decreases. Obviously, XC will start to decreases. That is, XC is nothing but capacitive reactance, we are going to call that one. So while the reactance of inductive component increases proportionally to the frequency, then what will happen? The capacitive reactance, that is called XC, decreases proportionally. Proportionately, it is going to decreases here. So this is the, which is effect to the system characteristics. It is now response characteristics. It is going to affect that one. If XC increases, then it is going to affect in the distortion. So what we have to use, the capacitor banks we are going to use for 3-phase, single phase and all the things. They have given some suggestions here. Now for 3-phase bank, if you are going to use the 3-phase bank, then use phase-to-phase voltage here. We have to use phase-to-phase voltage, and the 3-phase reactive power rating we have to consider that. You have to use the phase-to-phase voltage and 3-phase reactive power rating while calculating the characteristics or response characteristics of the power system. For the 3-phase it is now. For the single phase units, for the single phase capacitor bank units, we have to use the capacitor voltage rating and reactive power rating. We have to use that. So we can use the capacitive rating or capacitor voltage rating and the reactive power rating. We can use that. So this is the second one, that is called presence of a capacitor bank. Next we'll discuss about the resistive load. The resistive load, only we are not going to use pure resistive load, but during the resonance, when XL equal to XC is there, XL equal to XC, that is called the frequency under resonance, that is called natural frequency, we are going to call that one. That is not a fundamental frequency. Fundamental frequency is different. That natural frequency is during the resonance only it is going to come over there. So the third one we are going to discuss about effect of resistance and resistive load. The loads we are going to use not pure resistive, it is a combination of reactance, is nothing but inductance, capacitance we are going to use. So during the resonance, both XL and XC will be equal, and that condition the frequency, the natural frequency will also affect that one here now. So that is called resonance, we are going to call that. So loads and line resistances are the reasons why catastrophic harmonic problems from the capacitor on utility distribution feeders are seldom seen. That is rarely seen. We are going to consider them. Not commonly. These are errors, whatever we are the harmonic problems are there. That is not, seldom is nothing but not commonly, but that is rarely we are going to consider that one. Rarely seen, that is not common here. So that is not to say that there will not be any harmonic problems due to the resonance. We cannot say that one. Due to the resonance, we will not get any harmonic problem. Okay, but the problems will generally not cause physical damage to the electrical system components. The harmonics are there, but those harmonics, whatever the harmonics produced by the, that is capacitors, that is, what is that one here now? Resonance here now. Under resonance, because of the resonance, the harmonics will produce, but they are not problems, that is called, it will not damage any components and all the things. Physical damage, it will not do that one. So that one only they are saying here now. This is not to say that there will not be any harmonic problems. We cannot say that one there will not be any harmonics, but the problems will generally not cause any physical damage. Physical damage means suddenly I am taking the class, laptop will burst, that one. That is explode that. That is nothing but something is there in the power supply. You can consider that one. Or in the system, whatever I am using, that one, the electronics parts are there, something heat is there, that is the battery will burst and all the things. You can consider that one here. So next one, the most troublesome resonant condition occur when the capacitors are installed on the substation buses, either utility substations or industrial facilities here. Mostly during the resonance, where the problem is there, when we will install the capacitor banks or capacitors on the substation buses, utilities substations and the industrial facilities, on that condition, that is the troubleshoot or problems will under resonance, it is going to arise over there. In these cases, what it is going to happen, the transformer dominates the system impedance and has very high X by R here. X by R nothing but that is reactance by resistance ratio here. Now, if X is high or the resistance is low, on that condition, this ratio will be very high here. X by R ratio will be very high because of the low resistance here. For that reason, we are considering here now effect of resistance and resistive load here now. So if the resistance is low, that will very high peak value it is going to give here now. Suddenly it can, like this, the current or voltages it is going to increase. In these cases, where transformer dominates the system impedance and has a very high X by R ratio here. Now, X by R ratio high means that is R is very low. That is resistance is very low. We are going to consider that one. So the relative resistance is low. That is relative resistance is low and the corresponding parallel resonant impedance peak is whatever the parallel resistance resonant impedance peak is very sharp and high it is. So this is a common cause of capacitor here. Now during the resonance, if we are using a capacitor bank at the on the substation buses, so this is common cause of capacitor here. Now our transformer or load equipment failure will be occur that one. Transformer or load equipment failure will occur by using this common cause that is called rarely. It is not a common, but rarely we are going to use that one. So it completes the power system response characteristics. It completes the power system response characteristics. If you have any doubts, you can ask them. Any doubts? Give the reply. Yes or no. Yes means you can ask. No means I will continue. Fast. Any one of you?
No, sir.
Okay. So what we'll go? We'll go for the next topic that is called harmonics versus transients. I think so many people we have in the starting only we have considered that is harmonics. We have I will go for the starting first slide that is. Do that one, I will talk. See, the harmonics actually they are going to we are going to consider that is frequency domain methods here. Now, the frequency will changes instead of suppose one cycle fundamental frequency is there here. Okay, this is actually fundamental frequency. So time taken to finish one cycle that is reciprocal of that one. So that is called fundamental frequency. We are going to call that one. So here the time taken to complete here for one cycle that is called standard here. During the harmonics, what will happen? The same period during the same period of time what will happen? It is going to complete or finish 1, 2, 3 cycles over there. 3 cycles it is going to vary that one, and the magnitude it is going to maintain here. So combination of this fundamental and harmonics that is called distortion output we are going to get that. So that is called the frequency domain we are going to call this one. These harmonics are that is frequency domains here now. So and the transients is nothing but immediately when we are going to switch on the load and switch off the load. That time the frequency variation will be there here now like this. During I switch on only like this it will come. Next it will be normal. Next during the switch off again it is going to create some issue and it will be normal like this. That is called transients we are going to call it. During only when we are switching on and switching off the load, and that condition only the transients will come and it will not stay for longer duration. Fraction of second they will come for the normal frequency and normal voltages. But the harmonics will not come, it will take for the long duration here. No, due to some seconds it is going to take that one. Okay, so and it will the magnitude will also vary here now. And the frequency domain we are going to call. The transients are there, that is called time domain we are going to call that. We are going to call that is time domain we are going to consider that. We will discuss one by one. The harmonics represent distortion of the sinusoidal voltage or current here. So the harmonics they are going to represent the sinusoidal voltage or current signals they are going to represent over there. So why the harmonics will be producers? because of using non-linear loads. What are the non-linear loads? That is called some electronics devices, converters, and UPS, SMPS, battery supply. These are all the non-linear loads we are going to call it. Okay, non-linear loads means how we are going to call. What is the linear load and what is the non-linear load? If voltage is directly proportional to the I, that is called linear load we are going to consider. If voltage is inversely proportional to the current here, so by increasing the current, the voltage will heavily decreases like that. That is called non-linear load we are going to consider. Not inversely, that is not proportional here now. V is not proportional to I, and that condition, that is called non-linear we are going to call here. The harmonics will be caused by non-linear element in the system like saturating core, switching elements like thyristors, diodes, GTOs, and all the things. It is going to come here, SCR and all. Thyristor means SCR only. But the transients are, because of the switching on and off the load, they are going to produce here. The harmonics will be caused by non-linear elements here. So the Fourier series analysis of distorted waveforms shows that presence of harmonics, they are present in every cycle of the signal, but the transients will not present in the every cycle of the signal, only for the starting and when we are going to switch off that one. In two places only the transients will be there, but the harmonics will be present in every cycle of the signal. They are going to present. Next, the transients will consider transients which are also distortions here now. These are also distortions only, are present only for the limited period of time here. They are not continuous, but harmonics are continuous here. Every cycle they are present means that is continuous only. Yes. So the transients will be present for limited period. They are caused by the abrupt switching on or switching off of the load here. During the switching on and switching off of the load or occurrence of a fault, during the fault only they are going to consider here. See, I will tell that one. While in your houses you may experience that one. Suddenly you will switch on the button, lamp or switch dabaye on karne ke liye. Suddenly the spark or occurs, that one. That is called transients. You can call that one. कुछ काम कर रहे suddenly किधर तो short circuit हो गए, that is called fault. That is also, it is going to give the transients over there. So that is not, that is complete, that is a limited period of time. Within a fraction of second it will produce the light, I means arc method it is going to produce, and it is going to end over there. We normally use the time domain methods for the analyze transients. We are going to use the time domain methods, and for the harmonics we are going to use frequency domain methods. We are going to use for the analysis of harmonics here. So this is the important questions actually. So both are distortions only, but there is depends on the time, depends on how it is going to produce harmonics. Harmonics produced by non-linear loads or elements we are going to call. The transients only during the switch on and switch off of the load, or during the fault only the transients will be occurs over there. So harmonics will be present on in every cycle of the signal, but the transients are present for only limited period of time here now. So harmonics will be analyzed. We can analyze the transients by time domain methods, and we can analyze the harmonics by a frequency domain methods. So these are the major differences between the harmonics and transients. So if you have any doubts, you can ask. I'm asking you only. If you have any doubts, you can ask. Otherwise, tell no. रिप्लाई करने के लिए ही ना को बोलते आप लोग. Okay. Next, we will go for effect of harmonics here now. We have discussed about harmonic sources. We have discussed what are the sources for harmonics and how we are going to locate that one. How the power system responds and its characteristics we have discussed. And that is previous one, that's one. And what is the difference between harmonics and transients we have discussed. So now we will go for if the harmonics are present in the system, what effects we are going to feel. That one means in the system, what are the effects because of the harmonics, what are the effects, what are the changes will be there. That one we are going to discuss now here. So first one, just a minute. Deepak Khumbe. Khumbe Deepak, are you there? Roll number 40.
हाँ सर.
प्रेजेंट है क्या?
हाँ, यस सर.
Yes.
Yes sir.
What is the time now?
No sir, network problem.
Huh?
लेफ्ट हो गए थे सर, नेटवर्क प्रॉब्लम से.
लेट हो गई क्या?
हाँ, लेफ्ट हो गए थे अभी ज्वाइन.
That one only I am asking why you are late.
लेफ्ट हो गए थे सर.
Okay, leave that. So the effect of harmonics here now. How the harmonics will present for the longer duration, that much problems they are going to serious effect will be occurs to the power system or equipments where the harmonics will be present on that equipments. There is serious problem or effects. They sometimes that device or component will get damaged because of the heating and all the things. You can tell that. For the longer duration, we are going to the harmonics will be present for longer duration. That will cause that. And if the higher the amplitude of the harmonics is nothing but there is large amplitude or value, that is high value of harmonics, that will also affect to the devices or components it is going to cause that. That is normally it is going to consider the dielectric breakdown we are going to call that. When the over voltage will occur on that condition, the dielectric breakdown will occur over there. So that is the effect of harmonics, and the components may get damaged over there, and the temperature may increases over there because of the heat and all the things. Okay, so higher temperature it will give, some errors will be there. Okay, so many problems are there one by one. These all are the whatever I have pointed out here now. These all are the effects of harmonics only here. Effects of harmonics only I have pointed here now. So one by one we will discuss that one here. The duration presence of long duration harmonics here. So if the long duration harmonics are present, then those harmonics will cause more serious effects on the various equipments connected to the power system. To that power system, how many equipments are connected here? Now, various equipments we are going to connect that one. So because of the longer duration of the harmonics, it is going to affect, or it is going to serious effect or serious damage it is going to occur that one here. Next, amplitude of harmonics here now. Large amplitude harmonics of short duration here. Under resonance condition we are going to call this one here. Under resonance condition, large amplitude, that's called high value of harmonics, short duration only, within a fraction of 1 second, 2 seconds, fraction of second we can call that one here. But the value is very high, duration is small, value is very high, that will cause the dielectric breakdown here now, because of very high is nothing but it is going to create the over voltages. High duration, high amplitude of harmonics, those will create over voltage is here now. For that reason, because of the over voltage, the dielectric breakdown will be occurs over there. So that one only we have considered here now. Large amplitude harmonics, that is, but short duration. The amplitude is very high, short duration, under resonance condition. This point should be, you have to remember, under resonance condition can cause the dielectric breakdown because of due a large amplitude and short duration under resonance. It is going to create a over voltage problem here now. So because of this over voltage problem, it will cause the dielectric breakdown. It is going to cause that. It is going to cause the dielectric breakdown here. So next point, nowadays various devices and equipments being measured applications are more sensitive here now. So sensitivity of the product will be more as compared to the fast here now. So that will device, the sensitivity will be affect for the harmonics. We are going to call that one. If the harmonics will present, the sensitivity will be affected by the harmonics. So the capacitors used for power factor corrections. We are going to use the capacitors for the power factor corrections, and in different filters also we are going to call that one here. Leave that one. The capacitors used for power factor corrections, we are going to use the capacitors for the power factor corrections here. In different filters, decreases resulting, that is the filter in different filters, corrections, power factor corrections, and in different filters we are going to use that one here now. Decreases resulting in, that is called, what it is going to do by using this power factor capacitors here now, it is going to increase the current here now. Current drawn by the capacitor here. Now this capacitor is there, it is going to draw the current very high value, that is called more current it is going to draw that one. So in increasing in current drawn by capacitor behind permissible limit here now, we are setting the current here now, more than that, behind that permissible range or limits, this the power factor correction capacitor, it is going to draw that current here now. So that will also, because why it is accepting, why it is drawn the current behind the permissible limit, because of the harmonics under resonance condition. Because of harmonics under the resonance condition here now. Yes. Yes, somebody has talked, I think.
Beyond permissible limits, sir, not behind.
What is that?
Beyond permissible limit, not behind, sir.
Okay. Beyond, okay. Very good. That is called not behind, that is beyond permissible limit. That is more than that permissible limit. High, whatever the rating is there, more than that, it is going to consider. Here we are getting the rating, that one here now. So during that rating, behind means it will happen. So more than that we can, that is called higher rating value here now. More than that, higher rating. Beyond the permissible limits here now. Very good. Okay. Next, the capacitor acts as a sink for harmonic currents. That is, it is going to act as a sink for the harmonic current. Resultant effect of the harmonics is overloading here now. It is going to act as a sink, that one here now. It is going to collect the current. It is going to draw the current here now. Hence, it is going to, the harmonic, the effect of harmonics is act as a overloading here now. Hence, overheating, if the overloading is occurred, then what will happen? Because of the overloading, the heat will be increases. That is called overheating increases. Overheating will be occurs, then it is going to increases the dielectric stress and increases of the power loss here now. So overloading, that is called heat temperature will increases here now. So that temperature, it may be cause for the dielectric stress it is going to call, and the temperature is increased and overloading, because of the overloading, it is going to increase the power loss or the losses, we are going to call that one here. Lost are nothing but losses here now. Power loss, it is going to cause that one here. So this is the another effect of the harmonics over there. Next, the thermal stability or thermal limits are also there here. So the thermal failure of capacitor here now, if the thermal failure occurs for the capacitor here now, may take place because of the higher temperature here. If the temperature is more than that rated value, so that will cause us, because of the harmonics, that is overloading will occurring here now. So the heat will be increases. So if it is more than the rated, that is thermal failure will occurs, then the capacitor may takes place because of the higher temperature here. Now, thermal failure may takes place, thermal failure of the capacitor here. Non-sinusoidal power supply, that is called, it is not a sinusoidal power supply, non-sinusoidal, because of the harmonics, the non-sinusoidal power supplies or waveforms we are going to get here now. So results in reduction of torque of induction motor, that is this harmonics will also affect for the induction motors over there. So it will increase interference with telephone directory or telephone communication and logic circuits also. It is going to interface that whatever the harmonics are there. Now more we are going to get in the this places only, telephone communication and logic circuits where are there, that places only the, these all are the non-linear loads only we can consider that one. Because of that the harmonics will be increases over there. Error in reading of induction type energy meters which are calibrated for pure sinusoidal AC power system. If we are going to get the non-sinusoidal power supply, then while reading the power readings, the energy readings, we are going to call that one here. Whatever the induction type they are telling, now we are not using any induction type, we are going to use, that is electronic energy meter, we are going to call that one. That is called EM, we are going to consider this one, electronic energy meter here now. But in the induction type energy meters, that it is difficult here no, or we are going to get that exact value, we are not going to get that one. So that exact we are not getting that one means that is called error only. So these harmonics will produces because of the harmonics or because of non-sinusoidal power supply or waveforms, we are going to get the error in reading of induction type energy meters here. Because which are already calibrated, we are going to do the calibration, that one calibrated for sinusoidal, we are going to consider that. Example I will give here. What we are going to do, we are going to bring a dress for one person measurement. This same dress we cannot use for another person whose dimensions are different over there. So like that we are doing a calibration for the sinusoidal waveforms, we are going to pure sinusoidal waveforms, we are doing a calibration here now. Because of the harmonics, what will happen, whatever the input we have given, that is called non-sinusoidal power supplies, we are going to provide that one. So that one, it will create a error here. It is going to create a error. So these are the effects of harmonics, we are going to call that one. These are the effects of harmonics here. Just a minute. Okay. Next ones, still some effects are there, that is the higher order harmonics here now. So higher order, I told that is already, you told that one you have studied, then also that is 11th order, 11th harmonics, 13th harmonics and all the things. Higher order harmonics are there. Those higher order harmonics, they are going to cause, that is cause voltage stress and corona here now. Not corona means COVID-19 nahi hai. All of you know that electrical corona means what? Yes. In the electrical system, what do you mean by corona? Anybody? So voltage stress it is going to do, and it is going to cause the corona effect. We are going to call that one the high transmission line. At that places we are going to get the corona effect. We are going to call that one. Anyone, can you tell me? Diploma students are also there. and you have studied in the power system subject already. This corona, not COVID-19. Yes. I will ask randomly then. Deepali Medkari, rule number 19. Manas Sagar, rule number 30. क्लास भी अटेंड करते हैं और बाजू में आके बोल देते हैं सर मैं प्रेजेंट हूँ बोल के। बोलो अभी आंसर बोलो।
हाँ सर बोलिए ना।
What do you mean by corona?
Higher order harmonic causes voltage stress.
वो मालूम हो गए स्ट्रेस काज करते हैं वो बोल के। कोरोना इफेक्ट किधर होते हैं? Not COVID-19, electrical corona. I am telling that one.
Because of changing climatic level, moisture level, temperature level, there is a ionization of conductor. It is called as corona.
Okay, very good. Ionization of conductor, that is the word you have to use. So I think in the higher voltage side transmission line and all the things, I don't know, during the fog climate and all the things, here the transmission line is there. In this, during this transmission line, some violet or light yellow, the lightning system, you may heard that one, then the sound will come, that is very like a cerebral ki awaaz aati dekho, the transmission line. So here some color that is called violet color, almost we are going to call light violet, that is called corona effect, we are going to call that one in the electrical system. So see here, you can tell that one. Corona abhi nahi hai, pehle se hi hai. That is called electrical corona, we are going to call, that is corona effect here. Okay. So next one. The presence of harmonic in power system network can cause additional losses in the power system network. This also can cause the additional losses, overheating already because of overloading and non-linear loads. The current will be increases. It is going to heating will be problems because of the overloading, overheating of the transmission lines, the transformers, overheating of the transformers, generators, etc. We are going to consider that one. Even the malfunction or even failure of electronic or computer controls also occurs because of the harmonic here. Hence, it is clear that day by day, the increase in harmonic contents will impose new problems on operation of the electronic equipment here. So for the electronic equipment, it will create day by day, it is going to create the new problem, and it is going to create the harmonics, that is new propose of the new problems, we are going to call that one, which is causes or this effect to the electronic equipments, it is going to affect that one. That is called nowadays everyone is using electronic equipment only. Now the LED TVs are came, mobiles and laptops, computers. So these all are the electronics parts only. We are going to use that one here. Now inside that all electronics is there. So the energy efficient electronic equipment that will produce in future trends result in poor performance due to the voltage distortion. This book is written previously around 10 years back. That is almost the power quality subject is old actually here, no? So nowadays it is applicable now only here, no? The energy efficient electronic equipment that will be produced in future trends result in poor performance due to the voltage distortion here. Already whatever the voltage we are getting, that is distorted voltage we are getting here now, and like that, but the technology is improved here now. How the technology is improved, how we are already using a energy efficient equipments means I will consider that one. Previously we were using the incandescent lamp, that round bulb we were using that one, incandescent we are going to consider. That is a 100-watt bulb, the 100-watt lamp we were using the previous years. Okay, those are replaced by the fluorescent lamp, that is called tube light. These are replaced by the, so those incandescent lamps are replaced by the fluorescent lamps. Next, because of its size, the fluorescent lamp only for the industrial commercial buildings we were using. So for that reason, this fluorescent material, by using only, they have created some compact fluorescent lamp they have created here now, like this here now. Compact fluorescent lamp they have used. Now these fluorescent lamps are replaced by the LED now. Yes, we are using energy efficient lamps now. Yes or no? So we are using that one here. The energy efficient equipments only we are using. What is the wattage of this unit? This is 100 watt bulb here. 100 watt we were using in the previous. Now LED का rating क्या है? कितना watt use करते हैं maximum? 9 to 12 watt we are going to use that. 9 to 12 watt here. How much difference is there? 9 watt is enough for our houses now. Previously we were using that 100 watt bulbs. Now that is energy efficient lamps we are using that. So you can say that the in future trends that is applicable for today. Nowadays it is going to applicable. Hence it is essential to have proper coordination between the supply authorities and consumers. Where is sir? Consumers regarding the power quality problems here now. So we have to proper coordination should be there from the authority and customers regarding the electrical power quality problem, and what are those causes, what is it is going to result, and what are the solutions to eliminate those problems here now. This point you have to highlight. We are going to study the solution or monitoring system in the third unit here. So this completes the effects of harmonics, and we'll continue in the next class. Just a minute, I will mark the attendance. Now search. Okay, so we'll stop here only and we'll continue in the next class.